Welcome back. And today I'd like to discuss some of the functional attributes for atomic asymmetry and the origin of mass and charge. But I'm really doing that through a lens of the atomic singularity at the center of an atom. And I'm using that as a reference point to explore features of quantum tunneling and entanglement. So I'm suggesting that tunneling and entanglement is actually what's responsible for the baryonic asymmetry and the production of mass and charge from two photons. This is a different framework. It's not associated with the Higgs boson whatsoever. This is a supersymmetry inversion model that includes positron and electron pairs as a photon. So in hydrogen, this relates to how hydrogen can be used to create an isotope, and how two photons of light in a cross-space geometry provide features of the electromagnetic field in s orbitals and the positioning of a positron and electron pair system that is responsible for the creation of a proton and an electron, or a neutron and a positron. So let's just step through a few of the various aspects of the tunneling system, just to kind of get an idea of the framework that I'm using, because I'm not using quantum mechanics. I use an inverse square law relationship, which allows me to kind of explore atomic features of geometry down at the singularity within an atom, and the features of that singularity in the production of this entanglement system. So we know we get an outcome, which is a proton and an electron. So we know the functional outcome. We know in the W boson, W plus, W minus, beta plus, beta minus decay system, that an isotope or an unstable atom can release energy. And now we're kind of going, well, yeah, we can see a positron being released. And the current thinking in the current standard model of physics, we would say that the positron isn't there until the decay occurs and it's mediated through the W boson. I'm saying, well, I want to look at the features that turn that system in the reverse direction. So we are putting the positron back into the atom via the meson, via the W boson decay in reverse, to understand, if we reverse and play the video backwards, so to speak, we can see whereabouts the positron's actually hidden within the structure of the atomic nucleus, how it's connected to the neutron, and the relationships that are unfolded through a reverse trajectory of time. So that, in a way, provides us with some interesting conceptualized kind of frameworks to understand time reversal symmetry in the beta decay system that corresponds to the experiencing of time with the functionality within the unconscious part of the human mind. And we can get to those challenging topics at a later time. Let's first of all explore some of the functional features. So I'm just going to zoom in. And to utilize inverse square law is a way of kind of going, well, we know that two massive objects have a gravitational field that pulls them together in the Newtonian understanding, and the distance of r squared between them, if you go r, or the radius, considering that as a sphere between the two positions, we could go, well, what if we scale that down rather than from the perspective of the Earth and the Moon? Let's look at within one atom and look at the electron and the positron. Both have masses, so therefore both are drawn toward the center of the atom and that atomic singularity. Okay, so in a way, I'm applying that Newtonian logic of gravitational force to understand the singularity that's operating within the structure of the atom. And that's my initial frame of reference. And you can kind of get to that through Einstein's equations as well, where E equals mc squared and c squared equals E divided by m. And you can look at the right-hand rule of electromagnetism as 90 degrees, and therefore place E, negative E, M, negative M on a mathematical geometry of a cross, and you can understand the relationships between, well, the electric field and the magnetic field at right angles to each other to see at 90 degrees. There is at 45 degrees a photon of light. Okay, so that is the initial kind of reference frame, going in rather than out, getting closer together. And that's really that kind of first step shown here, the DM, the dark matter particle formation down at the singularity. So in this model, the blue dots have a diameter of 4e to the negative 18 of a meter, and the purple, smaller purple dot is 1.6e to the negative 35 of a meter, or the Planck scale. So two electrons, or an electron and a positron, when multiplied together, upfield shift down up to the singularity. So we get a singularity being able to separate into two, or the electron and the positron. Now, if we look at the square root part of the inverse square law, you would say, well, okay, you're unlocking the relative distance between r and r, the two objects. And in terms of the radius of the electron, the square root of the electron would give 2e to the negative 9 of a meter. So r times itself is r squared. So if you want to know what r is, then you actually have to square root it, right? So it's the square root of the r times r gives r. So in this case, the electron in this model has a radius of 2e to the negative 9 of a meter. And that's really the cool thing about the model, is that the inverse square law provides a way of exploring atomic structure. But at a supersymmetry inverted layer scale, you actually have to invert it, right? So you make it big, make it obvious. Okay, so the square root of the electron, or the positron, has this radius of 2e to the negative 9. And if we look at the inverse of the Planck scale, we get the 6.25 e to the plus 34. So what this model allows you to do is explore relationships between different scales. And it offers a solution for the cosmic microwave background, Hubble expansion. It offers solutions for the 1836 relationship between the electron mass and the proton mass. And it has features in this model that really provide a way of kind of looking at the atomic scale using mathematical constructs for features that we would consider as point light sources, because our current photon-based measurements don't have the resolution to allow us to explore the size of the electron. So we've been using Compton wavelength scattering to try to determine the diameter of the electron. Here I'm just going, well, I'm going to use an inverse square law relationship between the Planck scale and the electron scale. Here I'm going to use an inverse square law relationship, or the square root of the electron diameter for e to the -18 to give me a radius of 2e to the -9. The inversion of the Planck scale gives me 6.25 e to the 34, and I can take 4 of the radii of 2e to the -9, multiply them together to get the singularity. So I can take, in a sense, 4 particles, take them down to the singularity when combined together. So here are some tools that I'm using to try to understand what relationships I can explore. I have some very rigid mathematical constructs. So I can't use a framework based on statistics and probability. This is a deterministic framework through inverse square law, which constrains the model to give functional outcomes. Okay, so if we took 3 of the radii, then we get 8e to the -27. If you invert that, you get a number 1.25 e to the +26. So you become familiar with inversion of large numbers and small numbers. And when you take a large number and invert it, you get a small number. When you get a small number, invert it, you get a large number. You multiply the large number and the small number back together and you get 1. So the singularity state is the 1. And that is the balance of opposites. So when you square root, you have to square. When you multiply, you have to divide. When you add, you have to subtract. And in that way, you would say every action has an equal and opposite reaction. So the Newtonian physics-based atomic solution to the singularity model that's being developed constrains the model. It's a non-interactive logical state. So it provides a framework in which I'm saying, this is how the universe does what it does. And it doesn't require anybody or anybody else's input in order for it to do this, because it is, you would say, a created intelligence of balanced zero state singularity, or something weird like that, which nobody kind of comprehends or gets their head around. But if we break it down and go, well, here we have a singularity divided by the radius of the electron, we can get out to 8e to the -27. So that relationship corresponds to an energy distance of, you could say, 1.25 e to the +26 when inverted, and that corresponds to a 2 millimeter or 2 nanometer distance. A 2 nanometer distance away from the singularity. So in a way, the first orbital layer of the hydrogen atom, you would say, is at probably 91.2 nanometers. So, it's still a long way away from that, but that's kind of corresponding to the ejection of the electron out of the singularity out into the orbital layers. So this is a framework that allows the exploration of quantum tunneling and entanglement. Okay. Here we have 2e to the 9 times 4e to the -18 to give 8e to the -27. So not only do we have the division, but also the multiplication to give the same number. So we can look at, well, what are the kind of particulate attributes scale-wise, and that interaction between them that corresponds to particular features within the atomic process of tunneling and entanglement. So it's in a way, it utilizes the thinking of quantum mechanics, looking at the multiple solutions that could lead to the desired functional outcome. And it's not choosing which one it does, but it looks at, well, what's feasible and what's not feasible, what's restricted by inverse square law to a very narrow domain of potential possibilities. Okay, so if you multiply 4 of the 4e to the negative 18 together, you get 2.56e to the negative 70, which is essentially a doubling of the singularities. If we think about the division of a cell in replication or proliferation, we go from one parent cell to 2 daughter cells. If we think about the creation of positron-electron pairing out of the vacuum of space, that quantum energy of the singularity provides sufficient energy to get the inverse square law relationship down at 4e to the negative 18, and those scales provide you a conceptual framework for positron-electron pairing. Okay, so this model isn't some kind of guesswork, it is a deterministic framework to look at things theoretically, not using measurement, because we can't measure down at the singularity. We can use the lens of the singularity to look at the processes that are operating. And here we have a couple of other things. We have the 2 singularities, the 1.6e to the negative 35 multiplied together to give the 2.56e to the negative 70. We have the 8e to the negative 27 multiplied together to give 6.4e to the negative 53. So we can see relationships between the 53 and the 2.56e to the negative 70. We can see then an inversion of 8e to the negative 27 gives the 1.25e to the plus 26. The interesting thing about the kind of big orange sphere is that the square root of that is 1.11803e to the plus 13, and that's in the right range for meson energies. So all of a sudden, the numbers are corresponding to a meson field. If we think about that quark associated with the meson, and we think about the gluon quarks, think about them as separate. The gluon quarks inside the meson quark, and the meson quark quantumly entangled and connected to the orbital electron or positron. So in that framework, we can understand the beta decay system that's responsible for the handedness and why the electron is connected to, if you think electron is going to be negatively charged, it's connected to a quark that's also negatively charged. And the negative charge on the quark has come about through inversion. And so this decay process that flips the quarks from up to down or down to up, a negatively charged quark is a pointed up quark in the supersymmetry inversion model. And so we have negative up being flipped to positive down in order to get the neutron-positron exchange of beta decay. And what do we get out? We get out a particular electron neutrino, right? So you've got to look for the handedness that's associated with tunneling and entanglement. And that's what's giving the fact that, there are no right-handed neutrinos? No, because the electron is right-handed. And so the balance comes about that there has to only be the left-handed neutrino. And so the model provides a contextual framework through tunneling entanglement to create the asymmetry that creates the connection, the quantum entangled connection between the quark involved in the meson field and its connection to the orbital positron or electron. Okay, so we've got some key parameters that I've outlined. We jump back now to looking at the step-by-step process that's operating. So if we look at initially that dark matter particle formation from the He-BEC isotropic universe and that inward trajectory, and what we're doing is really setting up the exchange of and formation of positron-electron pairs. So that motion starts the process of forming the pi particles. I won't go into that here, but kind of step 2, we get a cross-space geometry, or the 4 particles, and I'm saying, well, potentially 2 of those could form the singularity as they go in. And so you end up with you could say an atomic division down from 2 to 1. So I haven't conceptualized a name for the reverse of a division, but and I'm sure there's something out there that would equate to that already, so I need to consider that. So from that stage, the 2 of the kind of 4e to the negative 18 can be converted into the 4 of the 2e to the negative 9, and then we have that relationship between the singularity, the purple dot, and the green dot through division, and that corresponds to the 8e to the negative 27. And so I'm looking at ways in which different things can come together to produce various features of the outcome that we know of, which is the proton with its 3 quarks and the electron, or the neutron with its 3 quarks and the positron. So if we explore from 6, then obviously we've converted the 2 green dots, so the 2e to the negative 9, into a 4e to the negative 18 in step 6. And then there's the inversion of the purple dot of the 8e to the negative 27 to give 1.25 e to the plus 26 in stage 7. And if we then go look at stage 8, we're saying, well, we could do a square root. We've done an inverse in step 7. Here's the square part, or the square root of that, where we will get and a square of the green. So we're changing what is 4e to the negative 18 to what is the 2e to the negative 9. So we've got that exchange occurring here. Then we've also got a new relationship between the green 2e to the negative 9 and the 1.25 e to the plus 26. And what we get is another singularity. So I'm just exploring potential ways of looking at changes that are happening within that atomic landscape and using mathematical calculations of inverse square law to allow me to explore that. I'm not saying this is right or wrong. I'm just saying, oh, I've got these mathematical model and the tools in which to look at numbers that we can't get to using measurement. So this is outside of measurement, and it is in a framework of supersymmetry inversion with revised quark charge calculations that aligns with the cosmological features of the universe based on its composition that we know of today. So if we then explore how they could all kind of connect together, because I then divide my singularity into two, kind of the electron-positron pairing, and then I'm putting the positron and electron inside of my meson. And that relationship really allows the connection between the quantum entangled electron that's going to be on the outside. So in 11, they kind of come together and produce this idea that the meson's connected to the quark that surrounds the gluon quarks. And we have an inverted symmetry. It has to go in through the singularity, get inverted to actually change its charge from 1 to negative to positive, or from positive to negative through that inversion step. And then we get that entanglement process occurring where we get a neutron and a positron in step 13. And so there's a very much an entangled state within the atomic structure of an atom, where this kind of meson field energy corresponds to an inverse square law relationship to the positioning of the electron into the orbital layer, or the positron into the orbital layer. And those kind of mathematical calculations provide a foundation in which to explore the processes which potentially could be operating within an atomic singularity. And most people would say, well, you can't see down there, so you're just making all this up, and it's just kind of ludicrous. Well, I'd say that we see through the decay process, beta plus, beta minus, that a particular set of energies in that e to the plus 13 region are observable for different atoms. And that squared gives a distance in Planck lengths corresponding to, that first outer layer of the orbital system. And if you look at some of the other calculations, where 5e to the plus 27 divided by 6.25 e to the plus 25 gives you 91.2 nanometers. So we know, in a sense, how many Planck lengths give 91.2 nanometers as that first n equals 1 orbital layer of hydrogen. And what people haven't, I guess, explored or understood is that in the supersymmetry inversion model, we can take the average of the velocity of the alpha particle and the average of the velocity of the speed of light, cube that, and we actually get a number that we then divide by 6.25 e to the plus 25, which is a conversion factor, converting Planck distance into nanometer, and that corresponds to 13.58. So anybody who knows the ionization energy required for hydrogen to release that electron is 13.6 electron volts. So this model identifies essentially 13.6 based on the velocity of alpha particle emission from the He-BEC isotropic singularity, and the C cubed V cubed average divided by the 6.25 e to the plus 25 gives us a nanometer EV relationship, which is just like, what? Where did that come from? Well, it all came from the He-BEC isotropic universe. So I think this model shows a credibility that hot Big Bang cosmology doesn't. So I'm saying that the asymmetry that we're seeing is really due to quantum tunneling and entanglement and turning light into atomic structure, turning something that had no mass and no charge into something that has mass and charge. So truly magical properties of the universe corresponding to the symmetry of photons going to asymmetry of baryonic matter. And so really we haven't got a problem with baryonic asymmetry from the cosmological perspective, because there was no hot Big Bang, there was no nuclear synthesis in that model that corresponds to any semblance of reality. And the reality is that there was a very cold helium Bose-Einstein condensate at the start of the universe that emitted alpha particles that corresponds to the inflationary phase of the universe. And this asymmetry only comes about through quantum tunneling and entanglement, which is really responsible for the formation of atoms from light. And when we shift our perception of reality, well, when we learn something that no longer makes sense in the standard model, we can see the flaws in the standard model. We can see them because of the quark charge calculations of fractions and adding rather than whole numbers and multiplication. We've normalized using an approach that has no connection to reality. And if you really want to understand the quark charges, then you really have to understand Coulomb charge as a surface area on the electron of the 2e to the negative 9. You invert that and you get 5e to the plus 8. 5e to the plus 8, that has a relevance to the speed of light. That has a relevance to the 1.602 e to the negative 19 coulombs if you work out the surface area based on the radius of 2e to the negative 9 and its inversion. So I would say that, materialism is coming to an end. It is a reductionistic model based on the hot Big Bang cosmological understanding. Again, James Webb Telescope showing us no hot Big Bang. This supersymmetry inversion model is showing us no hot Big Bang. This is showing us it's a cold helium Bose-Einstein condensate, and alpha particle emission at faster than the speed of light gives a negative time dilation and the expansion of the universe. So we are developing knowledge that goes beyond the standard model of particle physics. It corrects the quark charge calculations and it starts again from the He-BEC isotropic universe. Thank you. Take care.